Okay. Hello, everyone. I'm going to present today our paper ST-DETR, which stands for Spatio-Temporal Object Traces Attention Detection Transformer. Okay. We will first talk about the motivation of our application, then walk through our methodology and show our experiments and results and final conclusion. Okay. Let's start by the motivation. In this paper, we are tackling the moving object detection task, which is a fundamental task in the computer vision domain, which attracts more and more attention in recent years because its potential application in video surveillance and autonomous driving. Motion cues is crucial for moving object detection. In this paper, we are using the optical flow as motion cues besides appearance, which are represented by RGB frame. And the optical flow is generated using FlowNet version 2 architecture. And before saying our methodology could be extended easily and directly to cover another task like video object segmentation, and we are currently working on that. We are trying our architecture on dataset like Davis or YouTube VOS. Here are abstracted view for our proposed architecture. We mainly adapting the standard vision transformer architecture, which is called DETR, by extending it to cover more consecutive frames as input. We include the motion information using two ways. The first one is optical flow, as we said before, and the second way using multiple streams as shown here. By saying multiple streams, I mean the RGB and optical flow, which is repeated T times, and T represent temporal window, and we will talk about this in following slides. We treat the temporal frames as a sequence in both space and time dimensions, employing the full attention mechanism to take advantage of the feature correlation over both dimensions. This abstracted overview for extending DETR to handle two streams. For example, the first stream here is fed by RGB frame, and the second one could be fed by consecutive frame or by optical flow. And here an ablation study between the motion feature effect. Of course, intuitively, RGB and optical flow achieves the best accuracy. Here we are investigating the effect of temporal window size, which means how many frames or streams will be beneficial for our task. Only one step represents the standard computer vision transformer or DETR, and here we test 2 steps and 4. We evaluated the effect of increased window size, and the results show increased performance with the increase of T. However, a saturation barrier is hit at 4 time steps. So we stick to only using 2 streams. And we are proposing 2 variants for dealing with the temporal aggregation. The first one is early temporal aggregation, and the other one is late. Here we are represent the temporal aggregation after the backbone and before the transformer encoder using the TPE, which stands for temporal positional encoding. It's mimicking the standard spatial positional encoding in DETR, which includes the pixel location in the frame. But here we are encoding the frame ID in the sequence. For example, if you are using 2 consecutive frames, so we want to include this is first frame and this is the second frame, and so on. And for the late temporal aggregation, we using a shared transformer for each stream and another transformer decoder to learn the temporal information and fuse them before producing the final query. And surprisingly, the early temporal aggregation or the early variant achieves better accuracy than the late one. And here are the effect of using TBE. Without TBE, there are drop 2% almost. And by the way, we are using the standard equation for encoding, just sine cosine. And for pre-training weights, we are using Cuckoo because our used dataset, which is called a Kitty mod dataset, is a tiny dataset. So the transformer is overfitting. So we need to use a pre-trained weights. And here are the image resolution used in our experiments. And to conclude, because of the time, the employment of explicit motion features through optical flow together with appearance features through the special RGB frames produce the best result as shown before. And we present a novel method to handle multi-step sequential frames through temporal position encoding, TBE, and early embedding shows better performance due to the limited window horizon in our experience and the limitation in the dataset size. And feel free to contact me via email or LinkedIn. Thank you, and I hope the presentation was clear enough and beneficial for you. Thank you. I'm open for any question.
Thank you. We have a question for Eslam. So let me have a quick one. According to my understanding, you take a window of several frames, right? And do you get a detection for every frame or just the final frame in the window?
For our application, we only detect the objects from the current or the latest frame, but it's easily could be extended to output detections queries for each frame. Actually, we are using this as a trick, as auxiliary loss. We are outputting detection outputs for each frame, but as auxiliary loss, not the main task. But for the main task, we are only detecting the latest frame.
I see. Thank you.